Looking at this polynomial function, determine if this is an even or an odd degree function, and whether the leading coefficient is positive or negative. Well, if you look back at your notes, you'll notice that anytime you have an even degree function, the end behavior, that means on the far left or the far right, are either both going up or both going down. Since I can see that with this polynomial function, it's going up on one side and down on the other side. It's going up on the right and down on the left, the end behavior. This would be classified as an odd degree function. Also with this end behavior, if you look into your notes, when the end behavior says, as x's approach the right, the y's go up. As x's approach the right, the y's go up. And as x's approaches the far left, the y's go down. You're going to notice that this belongs with a positive leading coefficient. Now, if you don't have this in your notes, go back to today's lesson to write that down. On this polynomial function, we can see there is exactly one real root. Is this an example of a polynomial? Remember, there's two things that can't occur. One is the exponents cannot be variables, letters, and the exponents cannot be negative numbers. That's not the case, so yes, this is an example of a polynomial function. Now, if they asked you to write it in standard form, this is the highest. And they may ask a question like, what degree is this? So once I have it in standard form, I look at the highest exponent. It's a 5. I can go back into your notes, and 5 is quintic. Quintic is the degree. The leading coefficient is a negative. First, I'll start by writing this in standard form. Is this a polynomial? Again, I'm looking at the exponents. They're neither negative or variables, so yes, this is an example of a polynomial. It is degree 3. Degree 3 is referred to as cubic. The leading coefficient is -5. If somebody asked you how many terms do you see here, there's a total of 3 terms, so this would be considered a trinomial. Is this an example of a polynomial? By nature, most students go, it's positive, so I'm not worried about negatives right now. By your first glance, you don't see a variable in the exponents, but what you're going to see is that in order for us to be able to tell, this has to come up top. And when it moves up top, it has to change sign. So it was positive below, but when it moves up, it becomes negative. Now that they're all on the same level, now we can ask ourselves once again, is this a polynomial? And the answer is no. It's not a polynomial because I do have a negative exponent. This is another example of an equation that is not a polynomial because in the exponent position, we see it. If you're asked to evaluate using synthetic division, again, feel free to look up instructional videos on synthetic division. Mama method won't show up. That's just my own terminology that I use. I look for the highest exponent, it's a 3, and I write really small, x3, 2, 1, and 0. Then I put the corresponding coefficients. So 4 goes with x to the 3rd, 3 goes with x squared. There is no just x, so I have to put a 0 as a placeholder, and 2. And I'm trying to evaluate for 3. Remember, Mama method, difficult for a lot of students to initially grasp. You bring down the first number and then you follow. M stands for multiplying. This is our magic number. This is my final answer that I want to achieve. So 3 times 4 is 12. Now add straight down to get 15. Go back to multiplying. 3 times 15 is 45. Add straight down to achieve 45. 45 times 3 is 135. Add straight down, come up with 137. What does this mean? It means for function A, When I substitute in a value of 3, I get an output of 37. It also means that on a graph, if I went and found the ordered pair 137, it would be a point on the graph of the polynomial. I'm going to classify this as an even or odd degree function and do the end behavior simply by looking. So this is, it actually happens to be in standard form already. This is an odd degree function with a positive leading coefficient. So go back into your notes and find what is the end behavior when you have an odd degree function with a leading coefficient that is positive. The answer will be, as I go to the left, it goes down. As I go to the far right, it goes up. For this polynomial, the exact same thing. Is it even or odd? What's the leading coefficient? And how does that, without having to graph things, how can I predict the end behavior, just like the last problem? Well, notice that this is not in standard form, so I'm going to write it in standard form. And then I'm going to assess. So this is an even degree function with a negative leading coefficient. Look back into your notes. And when you have even degree, they either both go up or they both go down for the end behavior. When it's negative, they both go down. Hopefully this video was helpful.